priority. We've got to turn the project in early.
Hey everybody, how are we doing today? Everyone having a good morning today? Good afternoon? It is the afternoon. What is everyone doing? What questions does anyone have? Good to see Jake and Trace and Katie here. If you have questions right now, 320-474-201, ask those questions. I'm going to drink a little coffee. 1,000 points, 100 points for being here, 1,000 points max for the week. When will you post the info for the project on Canvas? It says this will be given later. Trace, I should have sent an announcement. Did you see an announcement this morning, Trace? I can show it via here. I'll pull it up on the screen here. There should have been an announcement sent this morning mentioning everything about where to go for the project. And I can show it here too. I can show all the info on where to go for the project. Project locations. Sorry, I'm logging in as we speak right here. Project locations, all this good stuff. But I sent out an email this morning. Do people already have I thought people had already turned in the project. I was like, whoa. Let's see right here. Okay, I'm gonna bring this over here and let me bring up another page and you'll see it here in 2 seconds. Okay. So we should have, let's go here. Okay. And let's see what other questions there are. So could we look at number 3 on You Bet, 474 You Bet? Oh, awesome. I'm glad you see it now. I sent out the announcement for, oh, there's Doc Brown. That's from the video last night right here. Back to the Future ending, go away, Back to the Future ending. So that's from the video last night. And so we're here on the webpage. Hey, what's up, Sakurab? It's good to see you here. Good to have everyone here. Let's go to the Stats 101 page. If you go to the announcements, you will see the announcement from earlier today. It also should be in your email. And I kind of listed everything I could to help. There's the video right here that goes through exactly how to do the project. Please, 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 please watch the video. Please start early and please ask questions. You got Alex. Let's do some 474. I think we'll do some 474 and 320. This project video right here is 7 minutes. So Trace, really good questions there to start. This project video, and here's the instructions for it, and then there's the project video again. This project should take around, I think, 30 minutes to an hour. But if you just do it really quickly, you'll make like a C or a D on it. If you watch the video and you take it seriously, you'll probably make at least a B. If you kind of ask questions, you'll make the A on it. I think a lot of people are going to write executive summaries and outros that just don't meet the guidelines of what you should be doing. So please, if you're in 201 and you're watching this right now, so I'm doing the first part of this video just on talking about the 201 project, please make sure you watch the video and I highlight key things you need to do. And so you need to like watch the video, well, because I could go through the whole thing now, but the video I did in a very, like I edited the video, I make sure exactly what you want to hear is in there. And then I repeat it about 3 times to make sure here's what you need to do. And you can always have me look it over. I can give a quick skim of it to make sure you're on track with your executive summary and your outro. Some people have been sending me theirs and I've been critiquing and improving them. This is definitely something we see students struggling with because in a business report, the executive summary should be the whole report. It should give the business problem. It should give the summary of the results, and then it should give the solution for the business. And then the outro should go into future ideas and new ideas from where do we go from here. And I go through all that in the video and I try to make it as clear as possible. So check out the video. The project is located here under the Projects tab, which this should also be on Canvas. There should be the Project tab on Canvas. This is the Stats 1 webpage. I'm going to drop it in the chat if anyone's watching. That is where the project is located. There's the instructions and the report Smokey wrote. So this is everything for the Stats 1 project. The best things to do right now are to watch the video going over how to do the project. And then here's the instructions right here. And I might even add this to the page just to make sure people don't miss the video, because I really tried to put out a concise video, because I can be long-winded at times, that really goes over what exactly do you need to do. So I think the first question was, Jake is asking about 474, number 3. So this is going to be 4 loops. So let me bring back up my screen right here. And let's go get that 474 question 3. Jake, you still here? Doing well? And then I see Alex has a question about 320. We'll do the 320 question next. So we've got a 474 question to start and a 320 question. How are you doing, Jake, with Legend of Zelda? What do I have? I have Back to the Future in here right now. Oh, no, I still have Zelda. Back to the Future took over Rocky Top. So we still got Zelda. I'm doing great too, Jake. Let's go right here. Homework number 3 on loops. I'm getting the homework up and ready. And we are good to go. Let's do this. It's Mega Mondays with a rainbow. There is a rainbow here right now on these Mega Mondays. Can I pull the rainbow down more? I'll worry about that later. I was working around with some stuff this morning. So that's where we have the new intro. We have a Smash Bros intro, but I'm a little afraid to use it because Nintendo will hit you with those copyright claims or copyright strikes. We don't want a copyright strike. So number 3. So I'm not going to exactly do number 3 100%, but I am going to talk through it. And I am doing the right one, right? Because this is the 4 loops. Okay, here we go. Yep. Okay. So with number 3, do we not have a place for number 4? Oh, it's not named. We need to name those chunks. Okay. So with number 3, you're doing basically a subsetting idea. And we have to do average GPA by pet. So what is the first thing we do when we create a for loop? This is a review for 320. 474 kind of, they've already done other topics you haven't done yet because they've done validation, lubricate, and other stuff. And they're going to do nested for loops and their assignments are generally longer. You bet, Katie, we got that next, probably about 15, 20 minutes. You bet, Katie, definitely. So hang out, Katie, we will do that. We'll do some chapter 5, part 2. That's going to be huge for 201. That's going to be some huge help for 201 right here. So Jake, what is the first thing we write? So don't leave, Katie. Or come back in 15 minutes. What is the first thing we write for a for loop? Skeleton. Boom. 1 sip of coffee. Get that coffee. Get excited. Here we go. So we need to write our skeleton. So I'm not exactly going to do it because I want everyone to still be thinking through how to do this. But when we write our skeleton, like let's say we have something like data survey 9. Oh, awesome, Katie. Thank you, Katie. 100 points, Katie. Thank you for hanging out as we write our code right here. And so we have data survey 9. So let's say I want to do something like, I'm going to do something very similar. Let's say I want to do something like the GPA of students. And you have to think about what you're doing. Don't just copy the code I write. You have to think about what I'm doing and why. So I'm going to store right here, average dot GPA. I don't like those. I just do this by gender. Okay. So this creates a blank vector. The reason you're doing this right here is to create a space to store the item. You're just saying, here's a box I'm going to put it in. Like this literally has nothing in it. This is a null object. It has nothing, no objects. Then I'm going to go, okay, I want to make a subset. And I'm going to subset the data survey 9. So this is the data I'm subsetting. I'm saying go to basically the Excel spreadsheet. So go to this Excel spreadsheet right here. And I want to subset only the males. So I'm going to go here. That just makes a new line. I'm going to say gender equals, and then male. And what does it not like? Oh, gender not found. Oh, this is the one that's like ex gender or xo2.gender. That's fun. There we go. That's why you run your code. You make sure your code works. So the variable is xo2 gender, and we saw that by clicking here, and we can see xo2 gender, and then we make sure our variable name conforms to that. So I'm going to call this right here sub, and I'm going to store into it. Now we've created our subset, and we confirm the subset is the subset we want. Now our goal is going to be to find the mean of, let's say, GPA, which is a lot like yours. So we go here to mean sub $, and we go to GPA, and that's the mean of the GPA for the subset. And now we store it in to the position. And let's store it into the position male right here. So there we go. We've done it. We've built the skeleton. So now, when you think about this, you're really close. I might leave it at this because this should be enough to basically get it because we have our skeleton. But now we need to identify, see if you can do this with me, Jake, right here. Identify what should be the placeholder. What should be the placeholder for this? What should be the variable? What will change when this loop runs? So what will be the placeholder thing that changes when this loop runs? What will be the placeholder thing that changes when this loop runs over and over and over and over and over again? What will be the placeholder thing that changes? Yep, male and female Sakura, 100 points right there. Great job. So this will become the placeholder right here. So let's put here male is the placeholder. I'm going to put this as a comment, so which means it's the variable. So it's the variable. And then what is the vector it will go through? So basically, Sakura put the vector it'll go through too, because the vector is basically male, female, which is the levels of right here. So levels, let's go here. Levels of, gotta grab this. I'm grabbing the wrong button things. There we go. Is the vector. So that's the vector it will go through. Skeleton is written. So I'm not going to turn this into a for loop. Is that how we spell written? Yeah, it's how we spell written, I think. So this right here has all the elements you need for a for loop. Like everything right here has all the for loop stuff. So we've created we know what the variable will be. We have to replace this. Like you're going to replace this with a placeholder right here. Like male is not, but it's, male will become, so male will become the placeholder, whatever is in that spot. Like male is not the placeholder, but it will be the placeholder variable we use. And then levels is what it will go through, which the levels has male and female in it. And then the skeleton is already written for us. So we just need to take this, insert the placeholder, and put it into a for loop. And we're just down to this part right here. How's this looking, Jake? And do you see how similar this is to yours? But does this make sense? And how are you doing on this problem right here? I think that's my goal, is to kind of push people to be like, okay, how would I use this for my code? And then to kind of get you right to the edge of where it's like, okay, that's how I solve it. Looks great. Yeah, that makes sense with what I have. Cool. And then you'll take all of this. Like you want to clean up your code afterwards, like look at it afterwards and like remove things it doesn't need. Like these are all just notes right here. So then you'll put this and you'll put this inside of here with your placeholder in the place, and you can reformat lines and everything. But I think that's good help right there. Here, we'll leave this just as is. Let's pull up some 320, and we can come back to this if you want, and I can address more questions, but keep asking questions. Oh, it is not my right screen. I need the classes over screen on this. Watch this. Magic. Now I'm on the screen. So there we go. I was like, where's my UT Marvel thing? Where's my UT Marvel? I paid good money for this. So let's go. I've got a really cool intro. I'm just so afraid. Too afraid to play it. I was talking about it on the Discord earlier. Let me pull up 320. What question was there on 320? I can go back and look, but if you are here with 320, we have associations part 1 this week. We're talking about some categorical data. If you're in 201, you remember mosaic plots. So who knows what we're talking about right here? Let's see. Let's go back. Let's do this. And where's so many buttons? There we go. So here we are back with 320. And so let's take a look. Which one was it on 320? Let me see the question on 320. The question on 320 was, oh, you haven't been able to look at the 320 assignment yet. Could you talk a little bit about F statistics? Yeah, of course. The F statistic, what is the F statistic that we're going to currently be seeing? So cool. Let's talk about p-values and the F statistic. Okay. So the function that we're going to use a lot for 320 right now, Alex, is going to be the associate function, association. So association is inside of regclass. So let's go here and look at association. And the format for it is y tilde. Now, I want everyone to take a moment and see where the tilde is at on their keyboard. It's right next to 1 and above tab. So the tilde, can I show it? Oh my gosh. The tilde, oh no, tilde is right here. Tilde is right there in the corner. I have to reorganize as I knock things over. The tilde is right there in the corner. The tilde is right there in the corner of the keyboard. So that's y tilde x, and then we have to do comma data equals. Y tilde x comma data equals. Y tilde x comma data equals. So I'm trying to figure out, there we go, that's better. Y tilde x comma data equals. Y tilde x comma data equals. And so this is the name of the data frame you will use. Y tilde x comma data equals. So you have to know this format because you have to know the y variable goes here, the x variable goes here, and the data frame goes here. This format is very important. So let's use this and run some data right now. You know what? We're going to do a question that is on your homework assignment. We're actually going to do the association between And I have to go into survey 9 right here. Let me run a code that's gonna go away. I didn't even know what I hit. Let's go to attach, and we're gonna attach survey 9. This makes the vectors available. Let me type in sitting location, I think it is. Really? Sitting location, there it is. We're gonna look at sitting location by gender. And then we're gonna look at data frame is survey 09. Now you don't have to run, I could have done it without that, but it would cause problems. But Alex, does this make sense here? The general format of this code is y tilde x comma data equals. Does that make perfect sense that what you're seeing with my code, and I'll show it again, is that this is the y variable. That's the y, it's what we want to understand. This is, yep, and so this is y tilde x, comma, so you see here y tilde x, and then, so that's the formula format, and then here data equals df. You could write data equals, like if you do that, but y tilde x and then data equals, you can just put, I think you can just put the data frame. Actually, you know what? Maybe I'm wrong. Maybe you have to do data equals. My brain's telling me you have to, but turns out you don't have to. Y tilde x comma data equals. So you can do data equals, or it's just the third argument. Let me decrease font size here, make this look a little better, and let's talk about the F statistic. So we're zooming out for a moment to like view the F statistic. Just because that wasn't loud enough. What's up, Mohammed? Good to have you here. He came in just in time to look at this graph. So here we are with the F statistic. The F statistic is a ratio of the observed over the expected. So the F statistic right here is going to be the observed, ooh, rainbow pen, over the expected is the F statistic. The F statistic is the observed over the expected. So what do we mean by this? We got Space Pen here to help out. So the F statistic is also the sum of all the cell chi-squareds. So the F is also equal to the sum of all the cell chi-squareds. Okay, so we have two important things right here. The F is equal to the observed over the expected, and the F is also equal to the sum of all the cell chi-squareds. Let me point the difference right here. This one's the theoretical, like understanding the theory behind it, and this one is the pure mathematical. So this is the pure mathematics right here. So this one down here at the bottom is the mathematical way we calculate it, and this is the theoretical way of understanding it. If the F is equal to 1, it might make it easier to see here. If the F is equal to 1, what would that imply? So if F is equal to 1, that's a horrible pen. If F is equal to 1, then what would this imply? So if you have an F equal to 1, then what would that imply about the observed and the expected? Exactly, we observed exactly what we expected to see. Like if we expect to see 10 and we observe 10, then the F is equal to 1. And this applies to this example. This is why I'm bringing this up. Because in this example, what do you see in this graphic? The F is very close to 1. So this is the F statistic in this graphic. So what you're observing here is an F very close to 1. So if you think about that theoretically, you're saying, I observed about what I expected. Now, if the F was equal to 2, that means what you observed was what? If the F was 2, then what you observed was what? A factor of what more than you expected? If the F was 2, it's like a ratio. What you observed something twice as large, the discrepancy you observed. So it's a ratio of the discrepancy. So the discrepancy right here visually is the separation between these. And so you can't actually compute it. I mean, you can kind of visually think about it, but here's what it would look like. In F of 0, I'm going to do it just as a chi-squared with just a 2 by 2. Where did my black pen go? I need to add like way more pens to this. Can I go? Sure. Let me go to a black pen on this. Okay, this is gonna, no wait. One of these days I'll make all the pens I want and everything will, oh, that's not what I do. Okay, so check out this right here. This is just a quick drawing and we're gonna talk about some possibilities here. Okay. There we go. So these are black and white drawings. And I want us to think about the F statistic on all of these. What do you think the F statistic for the first drawing is going to be? What do you think the F statistic for graphic A will be? What is the F statistic for graphic A? I can tell you that one exactly. Graphic A is perfectly flat across. Any guesses what, with graphic A, the discrepancy we observed is what? Of what we would have expected. Oh, it's so weird. Why? So the chats are showing up differently for me. I wonder why. I'm going to try one thing real quick. Sorry, everybody. I see the chat in the right, but I don't see it in the left. 2 seconds. I'm going to reload my chat thing. That happened before, and I don't like that. Am I currently still? Hopefully you didn't. Okay. Sock rub and everybody. Great job. And now I've got the chat reworking. It's so weird. And sorry if I missed any comments right there. This right here, this discrepancy, I wonder why the chat just stopped. This discrepancy on graphic A would actually be 0 because there's no discrepancy. Does everyone see how there's no discrepancy? They're perfectly flat across, so there's absolutely 0 discrepancy between those, and so there's no discrepancy at all. Now, what about graphic B? The discrepancy between these is larger, so what do you think the discrepancy for graphic B would be? Yeah, but so you're seeing it now. That one has no discrepancy. That's the only one we can know for certain. We can theoretically talk about the next ones, but since that one's completely flat, I can tell you for certain the discrepancy in that one. I say there's no discrepancy. So we observed 0% of the discrepancy we would have expected to see by random chance. So, and there's a lot to talk about this. This is a big topic. So with graphic B, what do you think the discrepancy here might be? This one's purely theoretical. There is no right answer. I mean, there's wrong answers. Any negative answer is wrong. 0 would be wrong. So here, the discrepancy might be something like, let's say, 3. And it means that this discrepancy we observed here is 3 times larger than we would have expected by random chance. Now, the last one might be 20. Now, the last one might be closer to 20. Does that make sense? Like the last one might have a discrepancy of 20, suggesting to us that this discrepancy we observed right here is 20 times larger than we would have expected by random chance. Remember that the F ratio is the observed over the expected, so all Fs are merely the observed over the expected. So when we say something has an F ratio of 20, we're saying that the observed is 20 times larger than we would have expected, like by a factor of that. Like we expect to have this much, but there was a factor of 20 times more. But this right here on this very far graphic, this one right here, which I'm highlighting even more, is 0% of what we expected to see. There's no discrepancy. We expected this discrepancy and we observed 0 discrepancy. So the F ratio is 0 because there's no ratio. We had no discrepancy to talk about. That makes sense. The more discrepancy between the observed, exactly, that's it. You got it. And when you look at your graphic right here, if we go back to the original output, right here, is there much of a discrepancy between these? Is there much of a discrepancy between all of these? Is there much of a discrepancy between all of these? Yes or no? 100 points on the line right here. First person, is there much of a discrepancy between all of these? And you wouldn't, I mean, you can look at it like this, but I know, And so look down here. The discrepancy of almost 1 is basically saying to you, you observed exactly what you expected to see, like by random chance. And so that really gets into the last topic here of what are these? This is a huge topic for 320. Like this is on the test and this is major stuff. This red line is your discrepancy. This red line right here is your F statistic. Let's grab this graphic and let's talk about it. Because this is where people just don't understand what this is showing them. Like I have every semester people are like, I don't know what this graphic's showing me. I'm like, we have to review it. And they're like, no. Okay, let's go. There we go. Cool. Okay. I'll zoom in on it. Okay. So this right here on this particular graphic, and this only applies to this graphic, this is your F value. We'll look at other graphics like this, but this is your F value. This right here is about 80% of the curve. And here's a hint. Someone gets their 1,000 points of the week very early if you tell me what this is, because this is the probability of your results or results from our scheme happening by random chance variation given the null is true. That quantity right here of about 80%, which is basically about 80%, is in definitionally the probability of your results or results from our scheme happening by random chance given that the null is true. What is that? What is Brian talking about? It's the probability of your results or results from your team happen by random chance given the null is true. Something we use to reject the null or fail to reject the null. It's how we look for statistical significance. Boom, Colin right there. Got your 1,000 for the week. And Alex, why not? You both got it too. So you will see confidence interval on here in a moment. You probably looked at the output, Alex, and I'll explain what that is for a moment. This is just the actual p-value of the test. Both of you get the points right there. So this is the p-value of the test. And you remember how I said the p-value is the probability of our results? Our result is this. Remember the probability of our results or results more extreme? And then the random chance are all of these things right here. These are the random chance. What it is, we make permutations. There's another topic if I start talking about that. Permutations are when we randomize the data and create kind of what-if scenarios. So the permutations are random creations of your data. It's like, think of this. I'm going to see if people's test grades are associated with how long they study. So let's talk about a permutation here for a moment. Here's what a permutation is. So with permutations, I'm going to have my original data set, and we're going to go with study and grade. So that's a G. My G's look horrible because I can't write. So we're going to go with your study, how long you studied, and what was your grade. So this person studied for 9 hours and made 100. This person studied for 1 hour and made a 50. This person studied here for 0 hours and made a 45. And this person studied for 5 hours and made an 80. Now, if you were to plot this out, this would look something, I made it like a linear relationship where the longer you study, the higher your grade. So you can see just briefly here that there's a linear relationship with the person studying 9 hours made 100 and the person studying 0 hours, 45, 5 hours, 80. There's some sort of positive correlation between this data, another type of an association. But what is a permutation? Permutations, let's do 2 permutations. What would a permutation of this data be? A permutation is basically this. Take your data, put it in a box, and just shake it up. Does that make sense? Who's with me on this? That if you want to make a permutation of your data, you put it in a box, and you just shake it up. You just go mix up that data. Because then anything we see between the variables would be by what? If we just mix up the data, any association would be by what? Keyword. Oh, we got to do it. Any association would be by what? You know it. Random chance right there. You know it, man. We love that random chance in class. So a permutation of this data could look like the following. And we could actually do it. I'll do it right here. I'll do it the non-real. Of course, I'm blocking that one. I'll do it the non-really random way because human beings are notoriously bad at being random. But here's 2 permutations of this data. All we do is we go and we mix it up, as in we just rewrite the data, but all mixed up. And we go here to 1,950,0591, 100, 100, 50, 50, 45. Oh, well, whatever. They both. It stayed the same. It doesn't have to get mixed up. I was trying to be random. But yeah, sometimes they stay the same. But so these are permutations of the data. I should make that more clear because the first one's not a permutation. It's the actual data. It's kind of the observed. So these are the observed. This is the observed. And then these are the permutations right here, permutations. So if you look how this kind of relates to what we're doing, it's a different type of data. But all of these right here, these permutations, are all of these bins. Like we create 500 permutations by default. And then the observed discrepancy is our discrepancy right here. Try to make that as clear as possible. Do the red again. Do the red. There we go. It's rainbow pen. So that is our discrepancy. And then we have permutations that build the other random ones. So we're looking what would occur by random chance, and this is a simulated p-value. So this is a big topic, and I'm really glad we introduced it today, but you have 3 key things to learn right now, I'd say, and we'll be going through this a lot in class. So don't worry, tomorrow we're going to be going deep into this topic here. But you have, when we're talking about here, the F statistic, which is the ratio between the observed and the expected. You have here the p-value, which is the probability of observing a discrepancy as large or larger than your observed discrepancy by random chance. And the random chance discrepancies are created by permutations. So how do we get all of these results right here? They're all like every one of these bins in these histograms are filled with random permutations. So when you look up here, these permutations up here are what by random chance? These permutations up here were what by random chance? These permutations right here on the far side were likely or unlikely by random chance. They were very, 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 very unlikely. And check this out. If we had landed, think about this. What do you think our p-value would be if we landed all the way over here? If we landed all the way over here, can anyone estimate the p-value? I ask questions like this on the test. I might say the F statistic is 11.8. Estimate the p-value. Can anyone estimate the p-value on that? Estimate the p-value if the F statistic is 11.8. A test was run where or I could have just put it all the way to the side and then we'd know obviously. So this one's going to have a very what p-value. And you can see, by the way, I shaded it. That p-value is going to be very, very small. And the easier test question is going to be this one. Estimate the p-value with a F statistic of 12.5. What is the estimated p-value with a F statistic of 12.5? Who can get this for 100 points right here? Who knows? I was trying to do 20 points this semester, and then I just kept on giving out 100 points. Who here knows what this p-value would be for 100 points? Hint. Those aren't underneath it. Hint, there's nothing underneath it. With a F statistic of 12.5, the p-value here would be 0. The p-value would be 0. And Alex, there might be one last thing I can mention because this is a big topic, and keep asking questions if you have it. But the only other thing you might be wondering right now is I think you saw where the confidence intervals are at. So when you think about how we interpret a confidence interval, the interpretation of a confidence interval is I am 95% confident that the true blank is contained in between the blank to blank. So I am 95% confident that the true p-value for this test is contained between the interval blank to blank. What do you notice is not in that interval that's very important for p-values? What is a very important value for p-values? And it's right there. So what this is showing you is we're trying to, yep, bingo, Alex. Great job, Alex. Another 100 points. The p-value of 0.05 is not in the interval. And so that means we can reject, oh my gosh, fail to reject. Very sorry. I was saying 0.05, so I thought reject for a moment. We can fail to reject, and we are confident in that because sometimes you'll get an interval that has 0.05 in here, and that's saying maybe the p-value is lower than 0.05 or maybe it's higher. You don't want to see 0.05 in this interval because 0.05 is kind of this tipping point. It's like deciding if you'll go somewhere and you're like, maybe I'll go, maybe I won't. And then you need to decide one way or another. You need to decide if this is statistically significant or this is not. And the confidence interval is giving you a confidence interval to estimate the p-value for this test. You might say, well, wait a minute, we can do confidence intervals for p-values? Yeah, because we're estimating the p-value via simulation. So the simulation could change where we can go to permutations, and we can go to permutations and do 5,000 permutations, and this will run a better, a more accurate test. If you notice my interval's tighter right here, we could go crazy and go to 50,000. Yep, let's do it. And while this is running, you'll notice that this goes from 78% or of the graph shaded to 80%. And then running here 50,000 permutations to estimate the p-value is going to give us an even tighter interval because it's going to make a better simulation. It's just a longer, better simulation. The reason you don't run this many permutations is because the reason I'm currently showing it takes more time. It does 500 by default, which is usually good enough for most things that are, either are statistically significant or not. And you notice how much tighter this interval is, but look, it's still right around 80%. And so this is just trying to estimate the p-value via random permutations. So when I changed that to 50,000 right there, what changed? It changed the amount of times it mixed up the data. Here's 2 permutations. It did 50,000 random assignments of the data, and then the histogram would have 50,000 bumps. The last thing I want to show that hopefully will make sense of this is what if I go here and I put random permutations to 5? These are my last questions. Can anyone here, don't look at the screen over on the right, can anyone here tell me the p-value? The random permutations was 5. Who knows the p-value on the screen? The random permutations was 5. There's only 5 permutations. You can count them. So what's the p-value on the screen? What is the p-value currently on the screen? There's only 5 random permutations. This is a really good test question too. Could say someone decided to run random permutations of 5. What is the p-value on the screen? And I like this test question. That's the F statistic. The F statistic right here is 1. The p-value will always be the probability of our results, which is the F, or results more extreme happening by random chance. So you need to shade these in and figure out what % they are. Keep going, Alex. You got it. These are good test questions. What would be the p-value here if you shade these in? What % of this is shaded in? There's 5 random results. So what would be the p-value? You got it. There's 5 results, and there's 3 right here. You got it. That's it. And you can confirm your answer by looking here. There's the p-value right there. You can do another one to double check. Okay, it looks right there. So what is the p-value right here? 1, 2, 3, 4. And with 4 right there, 4 out of 5, boom, right there. So does it make sense what it's doing when you, what's the p-value here? 1, because look, everything's above it. There's 1, 2, 3 results right there. There's the 4th, there's the 5th. Does it make sense what's kind of going on as we increase this right here to like 10, and you have 10 permutations, this p-value looks to be about 90%. Oh, it's 70. It's just because the line is hard to see where it's at. So that's 6 right there. So that's 60%. Yeah, no, and I think it does make more sense here. I might need to vanish right here. I don't have a Brian button for the screen yet. Boop. Okay, I'm out of the way so you can watch it. So you can try to see if you can estimate these really quickly. That's about 80%. Here, we'll put it on here. But then you can see, I can see the answer to that. It's 80%, 90%. See, it's because of the way the line is sometimes. Like it's hard to tell exactly like what's above it. 80%, 80%, we'll try to get a different one. 90%, and 80%. If it looks weird, it's just because the line is not perfectly on it. For homework 5, part 2, could you go over how you got a z-score? You bet. Let's do that. I think it's time for some 320 or 201. Let's bring Brian back right here. Brian's back, and so is Brawl, and so is Brian Jr. Let's do this. We got everyone here. Everybody's here. Let's do some 201. 2 seconds. Let's hop over to the main screen. 201 time. Let's do this. 201. How is 201 doing? How is 201 doing? Chapter 5, part 2. The big thing for chapter 5, part 2, as I pull it up right here, is to understand how to read the David M. Lane and how to use the David M. Lane. So let me pull up David M. Lane also. David M. Lane applet. Got that on the screen. And I'll be over on the screen in a moment so you can see it all. And then we pull up chapter 5, part 2 assignment. Where's the assignments? They changed how I log into my Pearson, which drives me crazy. Chapter 5, part 2 quiz. Settings for class. No. 2 seconds. We'll be in there in more like 20 seconds. 20 seconds. Countdown going. Replace questions. Good. Okay, we got it. Okay, we got everything we need. We got 21 questions. How many can we do in the last little bit of class right here? Let's hop over to the main screen. Let's see what's going on. Okay, we got Katie here and we got Trace. Good to have you both. Let's talk about some 201. So the question's about like the 90th percentile. Let me find one that asks for the 90th percentile. That's an easy one. And I'll make this bigger here in a second. Okay, good. Perfect one right here. Okay. So when we talk about percentiles on the curve, would you want to be in the 90th percentile of grades of the class or the 10th percentile? Which would you pick? If you could be in the 90th percentile of grades or the 10th percentile of grades, which one would you pick? Just 90th percentile of grades, 10th percentile of grades. Which one would you pick if you could pick one right now? I'm going to let you pick. You get to be in the 90th percentile or the 10th percentile of grades. Your choice. I can't promise you'll get it. But which one would you pick? 90th percentile, exactly. Because when you look at grades, if you saw something like this right here, and I'm going to click this button right here is key. Please note I'm clicking this button to enter in percentiles. If we have here the 90th percentile of grades, we would go here and we'd put in 90. We're not there yet. And then we'd go here, we'd put in like a grade distribution with a mean of 70, a standard deviation of 10, and then we do below. So the 90th percentile is also known as the what percent, the what blank percent, the what top percent. The 90th percentile could be also said to be the blank top percent. The what top percent is the 90th percentile. So if you look where the 90th percentile is, It's also known as the blank top percent. The 90th percentile would also be the what top percent of the curve. Who knows in the chat? Katie, 100 points right there. And who else knows? 90th percentile is also known as the what percent? It's a blank top percent. I have to give the answer away. The 90th percentile is also the top 10%. Does that make sense? The 90th percentile, if you saw it just a second ago, I'll put 90 in again right here. There's the top 10%. It's at 82.816. And then the 90th percentile is in the exact same spot. So the 90th percentile is the top 10%. And here, I'll drop this link in the chat right now. This one makes these questions so much easier. So you need to know how to read these curves. You need to know what they're showing you. And then the best thing to do is always label this. This is 90%. This is 10%. And let's take a look at the question right here. What are the cutoff weights for the top 10% of steers? Sorry about that. So the cutoff weight for the top 10% of steers, we're going to take 1158 and 82 and bring them over here. 1158 and 82. And it wants the top 10%. There it is right there. We got the top 10%. So let's put this in here, round to one decimal. What is the cutoff weight for the lowest 20%? We go right here and we can put the lowest 20, or we could technically put the top 80. So this is still right here if we do the top 80, which would be a weird way of displaying it, but I would rather do the lowest 20 right here, and that's going to round up all the way. And we go right here. Now this is where people get stuck. The middle 40%, we can do the middle 40 right here. Oh, that's so weird. I'd use the website. Oh, it's showing up on both. Good. Use the website, Katie. Use the website. It's much easier with the website. You can do it with the calculator with normal CDF or inverse norm. And feel free. I've got videos on that. So if you have the calculator, it's not bad to do it with. If you know how to use inverse norm or normal CDF. But 115 and 1201. 1145, I think it was, in 1201. So the website makes it way easier, Katie, to use the David M. Lane website, which we ended class with last time. That's 1115. I messed that up. I think I entered them all in the right way. Round to one decimal, round to one decimal. It's so easy to make a mistake. It's so easy to misenter these. And let's see if we'll do another one. Here we go. So this one, let's see. We're going to guess these ones. You ready? Okay. I think I can get these ones. Oh, it's going to be tough. There's some tough ones on this. These are tough, actually. I don't know if I can get these. Okay, you ready? So let's see here. Let's say we were doing this on a test and we had to draw it out. Now, on the test nowadays, we often give you pictures. So Katie and Trace, listen up. I'm going to make this as test relevant as I can. This is the what of the distribution. 100 is the what, and 20 is the what. 100 is the what of the distribution, and 20 is the what. So if you're watching this in the future now, you should instantaneously know this is normal curve, where 100 is the blank, and bingo, Trace. Great job, Trace, right there. And now it wants the highest 10%. So if I'm going to draw this on the normal curve, which we should be able to do, the test, we usually have you draw things, but since it's online, we don't. So here's what it would look like. We draw the normal curve. We put 100 here at the center. We go up, 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 down, down, down. We do 3 standard deviations because that covers 99.7% of the curve. And then we go up by 20 because the standard deviation on this was 20. So that's what we do right there. This is a normal curve with a mean of 100 and a standard deviation of 20. And then I always insist you put the z-scores below here. So putting the z-scores below here can really help as a frame of reference, and that's the standard normal curve. So the standard normal curve has the z-scores below it, and you can just see we're going up so many z-scores. So if someone said, my IQ is 160, I'd be like, okay, nice gloating right there, but you have a z-score of 3. Your IQ of 160 is a z-score of 3. If someone said their IQ was 150, you'd instantaneously know by their graphic that their z-score is what? Somebody with an IQ of 150 has a z-score of what? 100 points right here, who knows? Someone with an IQ of 150 has a z-score instantaneously of what? We automatically know their z-score by looking at this. It's pretty easy to do the calculations to see their z-score for their IQ is what? If they said 150. 150 would have a z-score of what right here on this graphic? Who knows? We'll see who knows. Got like 5 seconds. 1,000 points for the week, first person who gets it. Oh no, I'm going to have to say the answer. The answer is 2.5. And you are right. So that's the z-score for it right there. So you could actually solve it by doing that. Like the problem could give you the z-score trace. So let's say this was a test question. It might say the 90th percentile has a z-score of 1.282, but that's not going to be the IQ. That's the z-score. So if you look to where we would trace to, that would be right here. And that's the z-score you told me about, that 1.282. So I can actually use my calculator to solve, because that's how many standard deviations I'm going to go up. I'm going to take 1.2816, that's the extra decimal, times it by 20, and look right here, if I add that to 100, does that look to be about at 125.6? If I was a better drawer, probably it would look a lot better. But we can also confirm this 125.632 by going here and to the David M. Lane applet and enter in the mean of 100, standard deviation of 20, and do the 90th percentile right here, and look, the exact same answer almost to the decimal. So if you look at what we've done, we've come up with different problems right here. We could show you on the test this curve and ask you to solve, or we could give you the z-score trace. So that number you mentioned right there, that is the z-score. And what do we do with the z-score to turn it back into the number? We times it by the standard deviation. So I took this z-score right here of 1.282, times it by 20, and added it to the mean. And we wrote this formula out last time too. That was horrible mathematics, did something wrong. So we take the z-score of 1.282, times it by the standard deviation, and then we add that to the mean right there. Does that make sense? Oh, thank you so much, Trace. 1,000 points for you right there. That is a z-score is observation minus mean over standard deviation. Correct. I'm going to write both these formulas down. So the z-score formula is observation minus mean over standard deviation is a z-score. So that's how to turn something into a z-score. And to go back from a z-score, you have to do the mean plus the z-score times the standard deviation equals the observation. So this is what we're doing right here, where I take 100 plus 1.28 times 20. So this was when I found the observation. So if you want to find the observation, you simply just times the z-score by the standard deviation and add it to the mean. If you want to find the z-score, you find the observation's distance from the mean divided by the standard deviation. Is this making some sense right here? Both are just the algebra behind it, and we're just solving the equations we have right here. Does that make sense, Trace? And how are you doing on this assignment? This is a tougher one, but once you get the tricks behind it, you can be like, okay, wait a minute. I want the top 10% right here, and the top 10% is going to be this one right here. And so we go here and we put in this and 1 decimal, and then the lowest 30%, we go right here. We want to go to lowest 30. Here's what you need to do. You need to look at your graphic right now. And when you do lowest 30, you want to be like, is that the lowest 30? Oh, that's perfect, Trace. Great job, Trace. Does this look like the lowest 30? It does. Watch out, because that's the highest 30. That's the lowest 30. And you grab this right here. And then we've got another one that I think is going to trip us up right here. It says the cutoff value is between the middle 60%. So we go back here and we go to middle 60. And now we have to go between. And it's these two numbers right here. Can I take both of them? And let's try to do another one right here. One decimal, right? That's going to round up. It's so particular about decimals. Oops, I think I see another question here in 2 seconds. I'm trying to find the... How come we put 0.9 for the 10th percentile and 30 for the 30th? Oh, let me see here, Katie. Let me see. Hopefully I didn't make a mistake. That is possible. Oh, I think I see what you're saying. Okay, so this wants the highest 10% right here. So the highest 10% would be the 90th percentile. Does that make sense, Katie? So the highest 10% is the 90th percentile. You could, and let's make sure we got them all correct. They're all to 1 decimal, right? Oh my. They're all to 1 decimal, right? They are all to 1 decimal. I'm literally saying they're all to 1 decimal, right? And then I don't round it to 1 decimal. My Pearson, what don't you like those decimals, my Pearson? It makes sense now. Good. So the reason you could put in 10%, yes. So here, I'll show real quick on this. You're exactly right. If you wanted to do the highest 20%, you could do this right here and then look at the graphic. is this line right here where the highest 20% is at. Even though this is 80% shaded in, is this line right here, we're shading 80% of the curve and we're shading the below this, which is the bottom 80%, is this line where the highest 20% would be. Like, we're only looking at where this line is at. Does that line divide where the highest 20% would be from everything else? And it does. So I put in 80. And so watch this. Just keep your eyes straight on the graphic. Is that still in the same spot? It is. Now, if you want to see something interesting, watch this. Keep your eye right here on this line. Now watch this. That line is still in the same spot. Because the highest, or the middle 60% would have how much on the outside? The middle 60% has how much total on the outside. The middle 60% has how much total on the outside. So if there's 60% in the middle, what is the total on the outside? If 60% is in the middle, total on the outside would be how much? 40%. And if 40% is right here and here total, then that would make one of these the top 20%. So there's a lot of ways to find these answers. Like, we could literally show something on the test that looks like this, and you notice it's in the same spot as if we showed you something on the test that looks like this. It's important to know kind of how it works with this being the percent of area that's shaded. So this right here, watch where that line is at right there. It'll blink for a second, and then it's right back to there, which is going to be the same spot on the curve as if you did the middle 60%. Watch that line right there, and you notice it's still in the same spot. Is that making sense? How it's probably one of the toughest parts about this test right here is we can show you a graphic like this, and here's your key to this. Whenever you get a graphic like this, take this graphic and immediately start drawing on it. Well, we don't have it in paper anymore. But what you should do is you should be able to label it, or kind of on your scratch paper, 60%, and then this would be 40 total. And then you go 20 right here, and you go 20 right here. So understanding that right here is the 80th percentile, and here's the 20th percentile. Does that make sense? Hopefully, who's seeing how this works right here? Rainbow Pen is back. Super exciting. Say hey to Rainbow Pen. Shall we do another question? Trace and Katie, which one are you working on the assignments? Could you go over Z greater than when picking the graph in the... Yeah, I love that question. Trace, that is my favorite question on this assignment. I'm not even joking. You'd be like, really? Like, yeah, that's my favorite one. Is it around here? I know which one you're talking about. Wow. Is my favorite question. Okay. Let's do this. A Z greater than 1. So this is like shading the area at Z greater than 1. I think we got enough time for that, Katie. We got enough time for that next. You got it, Katie. So let's take a look right here. We're trying to shade a Z greater than 1. What's at the very center of this curve? What number is at the very center if this is the standard normal? Remember how the standard normal works? The standard normal I did with the Rainbow Pen right here. So the very center of this curve is 0. Nice job, Charlie. 100 points, Charlie. So we're saying we're going to plot Z greater than 1. So here's what we're plotting. Does that make sense? So it says plot Z greater than 1. So we're going to plot Z greater than 1, and let's go right here. And you know what? If you got this question, we can check it, right? Oh, do we have to do the whole thing? Sigh. 2 seconds. 2 seconds. Because I want to do it as we solve it. I'm going to pull it up so we can actually work it and solve it. I think people saw how to do that one. And 2 seconds. I hate working the quiz. Sometimes if you work it and you make an error, then you don't get to see your error. It's like you could make a mistake and then... Okay, so let me go back. Okay, we should be back on the main screen now. Let's take a look here. And the rainbow's back. 99 grass, my bad. Oh, no worries. Sorry. So now we're doing greater than 0.85. So we've got our little cheat sheet up right here, and we're doing greater than 0.85. So I would go here, and I'd go to the z-score, which we could erase these other numbers because we don't need any context to these. We're just doing the standard normal. And now we're going to do greater than 0.85. So I'm going to shade like this. Does that make sense to everybody? We're going to look for a graphic that looks just like this and shades greater than 0.85. And we get 2 guesses, which is the fun. So here's my graphic. That looks just like this right here. So take a look. There's my drawing. There's my graphic behind my head. And now I want people to think for a moment on this. Okay, above 1 is what percent of area? Above 1 is what percent of area? Like how much area is above a z-score of 1? If we were above a z-score of 1, exactly, the other ones just don't make sense because they're not, like, if you look at these, this is the drawing we basically drew, and here's our drawing right here, and if you look, it looks just like that. So we kind of made our own drawing for it. So above 1 is how much area? Above 1 is how much area? This could relate 16%. Nice job, Charlie, right there, 100 points. So this has to be what, if this is here, 1 would be here. This has to be what to 16%? This has to be what? Ooh, oh yeah, well, that's more exact. 15.85, I think, is more exact. Or it's basically 16, according to the empirical rule. So according to the empirical rule, 16%. So if 1 was right here and we're going this way, will this be more or less than 16%? Will this be more or less than 16%? More or less than 16%? More or less, because 1 would be right here and we're over here. So we went this way with our shading, a little bit more. So I'm trying to think. Okay, let me think. It's 1.67. Okay, so it falls off pretty quickly. Okay, it's probably like 19.8. Round to 2 decimals. Nope, we're wrong on that one. We get one more guess. And it's a percent. Darn, we got to go to the David M. Lane. This is how to solve these right here. So if you're watching, you have to go here, and let me drop it in the chat. So you have to go and do this, and you have to go to the following, and you have to go to the standard normal curve, which looks like the following. And then you have to go above 0.85. Let's see how close our guess was. It's 19.77. We were so close. The answer is 19.77 right here, and that's a little bit more than 16%. And we're doing above. So we were so close. It was 19.77. We almost got it. We got other tries in here. Final check, we got it good. Okay, so the next one says a z-score is less than 1.15. So now we're going to go below 1.15, A, B, C, or D. So pause here. A, B, C, or D. Where's 1.15 at? Let's do our drawing again to double check. And it says a z-score less than 1.15. And so we'd go here, and we'd shade below here, and that should tell you, that's the drawing I draw, below 1.15. And so which one is it? A, B, C, or D? Who knows for 100 points? Is it A, B, C, or D? We'll go off stars to 310. I can do the other question today. Which of these would it be? Because I did my drawing. So if you saw my drawing, which of these looks like it is B. Trace, great job right there. Now, remember how we said before, and I'll show you how I'm doing these guesstimates in my head. Does everyone remember we said, according to the empirical rule, that above here is 16%. We got to use the blue pen for this. Is that a good blue pen? It's space pen. Space won't work. So above here is 16%. And that means below here is 84%. So what do you think this shaded area above is? More or less than 84%? It's a little bit what to 84%? It's a little bit what to 84% because it's at 1.15. That would have to be a little bit what to 84%? A little bit what to 84%? A little bit what to 84%? I want to get this one. I want to guess it. A little bit what to 84%? Because you're going to go like this way over more here. So the answer is this has to be a little bit more than 84%. A little bit more than 84%. So if we're going to guesstimate this, it's going to be closer to 84, a little bit more. Exactly, Charlie. Great work there, Charlie. It's 1.15, 1.28. So 84 to 90, 88. I'm going to say 88.22. These are so hard to guess. These are in like a very hard to guess region. Oh, no. We're so close. I bet you we're so close to the right answer. 1.15. Here's a trick. This is the answer to question A, question B, question C, question D. So I'm going to go here for question B, 1.15, and it's 87.5. That should work, 87.5, because that rounds. And there's a little bit of, so it was 87.5. Oh, I should have went. There we go, 87.5. Does that work as the answer? Yes, it was 87.49, but there's a little give in the answer, and I like guessing these. It's giving me the hardest ones to guess right now. It's literally, I've guessed these before, but these are the hardest ones. This says a z-score that is between these numbers. So this is a z-score between negative 0.55 and between 5. What is the only one right here looks that the z-score is between it? The only one that looks like the z-score would be between it is this one. And this is a super hard one to guess. Watch me get it. Watch this be the only one I get. I know some additional numbers that people don't know. I know this has to... Yeah, you're probably right, Charlie. Charlie, give me a guess. Charlie, give me a guess. Give me a guess. Charlie, I'll give you your 1,000. I'm giving you your 1,000 points a week anyways. Charlie, you're here. You're working through these problems right now. Give me a guess down to 2 decimals. I know some additional numbers, and it's a hard one to... This is such a hard one to guess. Here, I'll take a guess right here. Ready? Oh, wait. We have to do this percent. I swear I used to do it as a decimal right here. I think they changed the way the numeric entry works on this one. You have no idea. I think that guess is too small. I think your guess right there is too small. Of course, I didn't delete that too. This was my guess right here. That was my guess, and I misentered it. So you see how it says between 0.55, negative 0.55 to 0.5? You have to go here to this one right here, between, and do 0.55. Watch Charlie be right. And it's 40.03. So we could have just entered 40%. There's enough. Enter the extra decimals. Be very careful if you're taking the quiz. Enter the decimals. It would have accepted 40%. I should just guess 40, and it would have been like, wow, it's 40. Or more like, it's 40. So, a good guess right there, Trace. Yep, kind of close to that. And it has to be less than 68 because it's between negative 1 and 1. Good, Trace. Great job following along. And then this one wants the outside. Okay, we can get this one. This is our redemption arc right here, everybody. This is our redemption arc because... Think about this. We're going outside of negative 1 and 1. Does that make sense? What does this mean right here? It means the absolute value of the z-score is greater than, if you have time with the graph, can you mention more about that, Katie? There's a few with graphs. If you can mention more about it, because I don't know which one. We can probably do that next here. Mention more details, and I'll do that next, Katie. You got it. So this one right here, the drawing is this one, because it's the greater than... Wow. Wow. So this one right here is that the z-score is greater in absolute value than 1 or negative 1. Because if you do negative 1.1, it'll go right here. Amber agrees. I love it. We'll definitely do that. Here's our redemption. You ready? I can do this. I can do this. I'm going to use something up here to help me out. We're going to get this answer. We're going to get this answer. 12.5. So let me see here. I just need to think for a moment. My brain needs to go and be like, how's this work? Wow. So, okay. That's that. And if we were to go a little bit more, because we're going less than that. Oh, my brain's just not working today. So it'd be like, okay, I think I got it. So it'd be 86. I'm going to say 86.5. Okay, 86.5. And 86.5, 13.5. No, that doesn't make sense. Okay, I'm just going to do it the normal way I thought about doing it. Oh, I see. It does make sense. Okay. 13.5. So this is 27. Oh, this is a tough one. Why are these so tough? Why did they make this a very hard quiz? No, it can't be like that. Oh, maybe it can. Okay, this is the last. Got to go faster. Last guess. Last guess of the day. Come on, redemption arc right here. Come on, redemption arc. Ah, Trace, I bet you're right. Trace, if you put it in, you could have in this time went to the David M. Lane. Trace, watch him beat the decimal. I'd love that. Trace, you probably have a really good guess right there. 20. Trace, you got your 1,000 points. If that was your guess, what was my guesses? Trace, that was amazing. Trace, right there. Great job, Trace. I think we got time. Did Katie? The question is: a company that manufactures rivets believes the shear strength. Cool. Let's go find that one real quick. 2 seconds. Let's hop back to the main screen. Let's go find that question right here. Trace. I was like, that's a really exact guess, Trace. Good job. If you knew how to, you don't have to guess. I do the guessing for fun. It's my favorite question. I really mean that. Probably of the whole semester, that's my favorite question. You guys are like, I hate that question, Brian. Remove it. That question should not exist. Wait. 2 seconds here. I'm pulling up the question. To get all the questions, I have to go like replace questions. Did that not work? Okay, cool. Because there's a whole list of questions that the questions can come from. There's 21 total questions. So if I pull up the general questions, then we won't see them all. And now we should be back. Oh, we're on that screen. Cool. Here we are. Skipping the transitions. Let's go ahead and look at the Rivet Question Company, a company that manufactures, and thank you very much, Katie, a company that manufactures rivets. And we've done a good sample of these today. We should be able to do the rivet one pretty easily. If you notice, they're all about the normal curve and just using the 6890. Oh, here we go. So can you post the link? Which one is it? I finally found the article for stagnation thing and has some business. Oh, are you talking about the, yeah, post the link in here, Andrew. Are you talking about the statistics now and then today? It's pretty cool. Or is it stagnation mentioned? Let me see what this is. Oh, what? Did it talk about? Oh my gosh, I'll have to look at this afterwards. This is so cool. Okay, that's... Oh, Andrew, you're in here. It's got your stat to 1. Cool. Okay, that's... Thank you so much, Andrew. Andrew, 1,000,000 points. You're not even in here. I should give Andrew those points. It's okay to see. Oh, it's fine. Look at me with my hair. This is... Oh, that's the wrong one. Let's do this. Here we go. Okay, so when we see the 77, oh, you know the mistake people make on this one? Here's the mistake people make. How many standard deviations? This is a great one. Amber, or I think it was Katie, thank you for asking. What is the standard deviation down here, and how many standard deviations is this going out? Does everyone notice that the numbers under the curve, this right here is actually how many standard deviations? This is the mistake everyone makes on this one. How many standard deviations is this going out right here? How many standard deviations is this going out? Be careful, because 68, 95, 99.7, 2. It's going out 2 standard deviations. So this shouldn't say 790. It should say what? Because the standard deviation is 40. It shouldn't say 790. It should say what? It shouldn't say too many. It shouldn't say 790. It should say what? Because it's 2 standard deviations. They're tricking you. They're showing you that it's 95, which is... be careful. Remember, a standard deviation is 40. David, 100 points. Its standard deviation is 40. You can see it right there highlighted above it. If you look where I've highlighted some text, a standard deviation is 40. So if this is 2 standard deviations, it should say 830. And that makes this the proper graphic. And then they're asking here, would it be safe to use these rivets requiring a shear strength of 710? 710 would be right here. No, don't worry. This one's pretty tricky the way they label their curve. Your best bet actually right here is to take the 750, 540 and to go over to this and go to mean 750 and right here. And then it wants below. And if you go to below 710, if we want them to have at least that shear strength, that's where the 16% comes from. So if you remember, below 1 standard deviation or -1 is 16%. And we can use the empirical rule for that, or we can use the applet. And I would say no, because we would have around 16%, about 16%, and that's obtained from this right here. About 16% of the rivets would have a strength less than 710. Be careful, they're not showing you all the numbers on this because 710 is right here, and so here's your curve right here. But if you draw all the numbers, which we should, you should see 710 is here, which is 1 standard deviation below. So we're going to say that this is not good. And then about what percent of rivets can be expected to fall below 830? 830 is 2 standard deviations above. Who knows right here? Let's do our trick. You ready? I got to move around the screen. Can I? Yes, I can. Yeah. Woo. Okay, let's do this. So last question of the day. Who knows what percent of areas between -2 and 2? I'm mirrored, so it's hard to do this. What percent of areas between -2 and 2? How much? You can see it up there. Wrong arm. Right here. 95. What percent is outside of here? What percent is outside of here? If 95 is inside, what's outside? 95 inside, what percent outside? 5. Then what is this? Above here is how much? Above here is how much? Above, you got it, Andrew? 2.5. So if 2.5 is above there, how much is below? How much is below here? If 2.5 is above here, how much is below here? If 2.5 is above here, how much is below here? Because above here is 2.5. How much is below here now? Above my arm is 97.5. Yep, bingo. So drawing it out, trying to do it that way is a really good way, and that's how we get it right there. You can also use they're wanting, see, wait. I'm going to purposely get this wrong. I'm just going to see if it takes the answer. So if you're like, Brian got it wrong. Okay, I got it wrong. Let's try to see if it would accept this answer, which is like 97.72. That's going to be scary if I know that off the top of my head. 97.72. Not that I've done this problem quite a few times. But, so I could have told you 97.72, but I think it wants the empirical rule. So it's going to count that wrong. It did. And it wants the empirical rule number, as long as it's below, yeah. Yeah, it wants the empirical rule number. So you have to use the empirical rule number here because they're showing you the empirical rule. So it's basically saying, oh, it does say use the empirical rule for all these parts. I just wanted to see if it would accept the David M. Lane. If they just put a little tolerance on that, they would accept it. But it says use the empirical rule. Why do we use the empirical rule? The empirical rule is something we can keep in our head at all times. So it's really good in that way. Like you can memorize the empirical rule and I can tell you that below there is about 97.5, or I can memorize the numbers that the applet puts out because I've seen it a billion times. But that's got it. That's the end of class today. And we've got the new Rick and Morty intro. This is a reminder to 201, and you'll be seeing this intro again soon. But let's see that Rick and Morty intro and get some advice for Rick. Here we go. We'll be back here soon. But once again, the Rick and Morty outro. Let's do this.
Morty, we've got to turn the project in early.